Good morning, everyone. Today we are going to learn basic concepts which are being considered while designing any structure using Etabs. So, in this, we are, as we know, every structure is to be designed as per the loads it is going to carry, and its economy is getting considered. So, in this case, if we consider a frame like this, as we know, every load it is going to be diverted or transferred like this from the slab to the beams, so beams to the columns, and from columns to the gravity. So this is the main thing we have to consider while designing, that load is going to be transferred to the gravity. Okay, there are several design consideration which we are going to look into this. Desired outcomes of structural design. The main consideration or the outcome is safety. The safety of the structure is main thing we have to consider. It is against structural failure. The second thing is economy. We always keep economy in our mind with the safety, and the third one is the structural members and its design. So at the time of designing with reference to economy, we also need to specify the structural members. Okay, so standard code for civil engineer in India is IS 456 for concrete, RCC concrete, and IS 800 for general construction in steel. Okay, so basically concrete grades that we use, is M20, M25, M30 and M35. In this M35, the 35 is compressive strength of concrete after 28 days. So it's a compressive strength. Okay, so steel reinforcement bar, for steel we consider FE 415, FE 500. Mild steel grade is FE 250. We always consider this. So member FE 250 and FE 345, these are the main steel members we consider for designing any structure. So now we'll check what types of frames and all we are going to study today. Okay, so this is a structure of frames in which the vertical members are called chords, the inclined members, these are the diagonal members, these are called bracings, and the whole structure, this is considered as story 1, or is a ground story or the base story. This is the story 2 or the first story. Okay, if we consider this is ground, then this is the first. Okay, and the distance between two vertical columns is considered as bay. These are the restraints. So bay is a distance between two adjacent columns, and bracing, it is a diagonal member This is the diagonal member in a frame provides stability against vertical load. The bracing provides stability. Okay, so in case of column or the column structure, these are the columns. The vertical members are columns, the horizontal members are beams. The vertical compressive frame members, columns are compressive frame members. Okay, so there are two types of loadings in the structure. One is axially loaded, another is eccentric loading. In the axially loading, the nature of loading is compressive. Okay, so in the eccentric loading, there are uniaxial and biaxial bending moments. So compressive loads, to undertake the compressive load, concrete beams provided by uh, reinforcement columns. So longitudinal. Okay, there are several types of loads on the building. After that, we consider those types of loads. These are gravity loads, lateral loads, steering loads, foundation settlements, and spatial loads. So in that, gravity loads, we consider first gravity loads. So in gravity loads, there are dead loads, that is self weight of the building, live load, that is so object or the furniture or that kind of load, which is live load. And the third one is gravity load is snow loads. Okay, and second load, lateral loads. In lateral loads, the loads are parallel to perpendicular to the structure. These are the lateral loads in which wind load and seismic load are considered. Okay, the third one is straining loads. In straining loads, this load is due to the change in temperature. Or shrinkage load. Concrete due to loss of capillary water increases internal cracking and external deflection. So in straining load, one is change in temperature and another one is shrinkage. Okay, the third type of load is foundation settlement. So in foundation settlement, sinking of foundation inside soil due to foundation not designed to complement bearing capacity of soil, and might also be due to the structure and foundation in near area. So foundation settlement is due to less bearing capacity and foundation in near area, near foundation. Okay, in spatial loads, there are three types of load. One is moving load, another one is blast load, third one is mechanical handling. Okay, so these are the types of load on a frame or any structure we do consider while designing. So IS code for loads, the first one is live load. Okay, for IS code for first one is dead load. For dead load, IS code is IS 875 part 1 is considered. For live load, IS 875 part 2 is considered. For wind load, it's IS 875 part 3. For snow load, it's IS 875 part 4 is considered. And for the special combinations or the special load, it is IS 875 part 5 is considered. Okay, so after these there are several factors that affects the dead load and the live load. These are the main loads we have to consider while designing any structure. As per IS 875 Part 1 and Part 2, dead load, it's a unit weight of the building material. In unit weight of any material, it is self weight. So for brick masonry, self weight is 18.8 kilonewton per meter cube. For reinforcement concrete, it is considered as 24 kilonewton per meter cube. For live load, as per the Part 2, IS code Part 2, it depends on the occupancy and type of the structure. So in live load, for bathrooms and toilet, we consider is 2 kilonewton per meter square. Or for concentrated load, it is considered 1.8 kilonewton. So for the large structure like classrooms or halls, operation rooms, etc., uniformly distributed load for dead load is considered as 3 kilonewton per meter square, and sorry, and 1.8 kilonewton for concentrated load. So these are the basic types of load we need to consider while designing any structure in Etabs. So this is the basic thing we need to consider while designing any structure. Thank you. Thank you for listening.